whole chapter has been based on trying to figure out what's actually happening in a solution. Like, that's what we want to know, like what is happening. So far in Intro Chem and in 219, we kind of have talked about everything in terms of a molecular equation. And so this is like every equation we've ever drawn, but these equations really aren't very important to us. So like, for example, when we take 229, you won't even write these equations anymore. And so what you're always going to be using is net ionic equations. And it's pretty much from now on in this class, we're just going to be concerned with net ionic equations. So we need to figure out how to get to those. Now, what a net ionic equation is it is what's actually happening in the reaction. So this is just a bunch of excess information. We want to know like what's actually happening in the reaction. So these are our molecular equations. A complete ionic equation is when we break everything up. So you've seen me today, I've been going, oh, this becomes K plus and OH minus. This becomes Mg2 plus and NO3 minus. I have been breaking these up for us, so you kind of get the idea of how we're thinking of these. So a complete ionic equation breaks everything up. So here's a much prettier way of doing this, right? So here's our 2 Ks right here, 2 OH minuses right here. And these plus and minuses are very important, right? This is why it's dissolving, because this ion is what's attracting that side of those water molecules to it, right? It's because of that positive there. So it is very important that you put the positives and negatives there, because without it, we're not showing that those ion dipole interactions are occurring. So here's your Mg. You have 1 Mg, its charge is 2 plus, 2 nitrates, 2 Ks, and again, 2 nitrates, right? Because it's kind of like, what is that? The distributive property when you multiply it through. And then we looked at the solubility table, this one doesn't come apart. And so therefore it stays together as a solid. That's the complete ionic equation. Now the next one is the most important. The next one is the net ionic equation. So the net ionic equation is what's actually happening in this reaction. And that's what we're going to be concerned with from now on. I want to know what's actually happening. So what's actually happening in the reaction is we created a solid. What created this solid? Well, this solid came from an Mg and 2 OHs. That's what created this solid. Now you see that this K is the same on the reactants as it is on the product. This NO3 is same on the reactants and the products. These are spectator ions. So these spectator ions are the ones that are the same on both sides of the reaction. So they are not involved in the reaction, therefore they are of no importance to us. They are just spectators. We call them spectator ions because, like, if you were at a sporting event, if you remember last time you got to go to any kind of event, spectators are like in the stands, they're not actually part of the game. This is what we're concerned with here, the net ionic equation. This is what happened. And so you'll see, if you take 229, literally you'll have this equation here. So you'll have this equation, but you won't even use that equation. You will just use this equation. And this is what we're trying to get to, is being able just to see and understand how to get to these net ionic equations. And some of you will get good at this really quick, where you'll just be able to see the net ionic equation right from the molecular equation. And that's sort of what we're trying to get to. So we're going to go through how we get to these net ionic equations a couple more times. So on these ones, you can see, again, here is what happened. Right? Here's what happened. A new state was formed. On this next one, it's a little trickier to see exactly what happened. So when we do this, we break everything up, right? So we have 2 K pluses. We have an SO4, 2 minus, 2 Ag pluses, 2 NO3 minuses, 2 K pluses, 2 NO3 minuses. So that's what it breaks up into. All I have is the answers here, so I can't show you them all. So we look at this and we look at what is the same on each side. Well, that's the same. Whoa. NO3, NO3, K, K. So what actually happened in this reaction is we have an AG, 2 AG pluses, 1 SO4, 2 minus, created AG, 2 SO4 solid. And that is the equation we care about, right? The equation up here has become of no importance to us very soon. This is what we want to get to. That's our entire goal. So now when we do it with this next one, so double displacement net ionics are pretty easy to do. Single replacement, gas producing, those are a little trickier. So let's go through this one together so you can see. So when we do this one, I'm just going to do this one neater for you. So this is 2 Na pluses, a CO3, 2 minus, 2 H pluses, and then again multiply through. So it's 2 Cl minuses, and again 2 Nas, and then 2 Cls. And then we have a CO2, which this is a gas, right? What holds us together? Only Fs, so chances are it's a gas. So we have a CO2, and then water. Again, water is a new thing. It's a liquid itself, water. So the question is, what made these two things, right? So the question is, what is the same on each side? When you do this, what's the same on each side? Na, Na, Cl, Cl. So in this case, this is what happened. This is what is going to be our net ionic equation. So again, you can see it's a little trickier when it's not just a straight double displacement reaction. So that's a little messy. Let me just delete this so you can see these. There you go, that's better. And so again, these, pretty easy. These, trickier. And so this is our net ionic equation. And so if you just follow that process of, again, you can probably see them from here. That's fine if you want to go straight to a net ionic equation. This is much harder to just see. So you need to go through the complete ionic equation. Again, the complete ionic equation is breaking everything up. So when they're difficult ones, you need to go through the complete ionic to get to the net ionic equation. Okay, and now that we know net ionic equations, that's pretty much all we're going to use. So this brings us to neutralization reactions.